Let's jump right into this explainer. Today we're taking a magnifying glass to a mind-bending historical puzzle. We're going to break down piece by piece this incredibly complex mathematical grid dreamed up by Benjamin Franklin. Our goal today is pretty straightforward. We want to take the raw historical data of his famous magic circle of circles and turn it into something you can clearly visualize, a true masterclass in arithmetic equilibrium. We're going way past the surface here to see exactly how a human mind, armed with literally nothing but a quill, some ink, and sheer intellect, built a flawless mathematical system. So let's get into the anatomy of this perfect balance.
But before we get totally lost in the math, I want to throw a fundamental question your way. How do we actually achieve perfect balance? Think about it for a sec. In our daily lives, balance is super subjective, right? It's a fleeting feeling. We try to balance our time, our budgets, our priorities. But today, we're looking at pure, absolute arithmetic equilibrium, a state where every single moving part interacts with the others flawlessly. Zero room for error. We're exploring that exact spot where historical philosophy slams right into unyielding mathematical rigor. It's basically a window into a mind that saw numbers not just as tools for calculation, but as the actual building blocks of a perfectly ordered universe.
Okay, Part 1, the 1765 manuscript.
So, everything we're dissecting today comes straight from one specific, incredible historical document. We're looking at an in-depth, technical breakdown of a manuscript that was mailed off to a guy named John Canton back in 1765. And yes, this is not a myth, it's a real, heavily documented physical piece of history. Picture this, parchment crossing the globe right in the middle of the Enlightenment, a time when the smartest folks around were completely obsessed with finding rational order in nature. Now, Canton was a big deal, a prominent English physicist and a fellow of the Royal Society. So Franklin didn't just mail him a fun little parlor trick. He sent this to share his intense obsession with geometry and perfection. This manuscript is our ultimate blueprint. It was Franklin basically flexing, proving that human reason could take the infinite chaos of numbers and lock them into a beautifully constrained, totally balanced system.
Moving on to part 2, 8 circles, 8 radii. Let's look at the structure.
Here's the physical skeleton of Franklin's idea. To really grasp this, we've got to visualize the grid before we even think about adding the numbers. First, notice the 8 radii. Picture a bicycle wheel with 8 perfectly straight spokes shooting out from the dead center, dividing the space up. Got it? Okay, step 2. Now layer on 8 perfectly concentric circles expanding outward like ripples when you toss a stone in a pond. When you cross those 8 circles over those 8 spokes, you get exactly 64 intersection points plus that central hub. It creates this incredibly tight mathematical canvas. It's kind of like a spherical Sudoku board, but, experientially more demanding. Every single intersection needs a number. And since the lines cross, each number belongs to a spoke and a ring at the same time. Change one digit, and you mess up the entire line and the entire circle. The architecture itself absolutely demands systemic harmony. No pressure, right?
Part 3, the constant of 360. Here's where the magic starts. The sheer elegance of this specific number, 360, is just mind-blowing when you think about the constraints of the grid we just built. Franklin packed a massive set of numbers into that web of circles so that if you add them up along specific paths, you always get exactly 360. And think about why that matters geometrically. A perfect circle is made of exactly 360 degrees, right? This wasn't some random coincidence. It was a deliberate, agonizingly complex choice representing total wholeness, rotation, and harmony. Add up the numbers along any of the 8 concentric rings, 360. Add up the geometric halves of the spokes, 360. Pulling that off just once is tough. Doing it repeatedly, in every direction, on the same board, that is a monumental mathematical feat. Every time you place a number to satisfy a circle, you risk wrecking the straight line it crosses. Making everything equal 360 without a modern computer is just staggering to even think about.
Part 4, the secret of the central 12. So right there, totally isolated in the dead center of this crazy geometric web, is the number 12. Our dive into the manuscript shows that Franklin used this specific number as the secret key. It is literally the linchpin of the whole operation. By dropping that 12 at the core, it becomes a gravitational anchor for all the math. Whenever a calculation cuts right through the middle of the grid, this central 12 balances the scales. Think of a physical seesaw. If you've got totally different weights on each side, you need a very specific, perfectly placed fulcrum to keep it from tipping, right? Well, 12 is Franklin's fulcrum. Plus, it's symbolically huge.
12 months in a year, 12 hours on a clock face, tying right back into the 360-degree theme of cycles and time. Take away that anchor, and the math on the cross-sections just falls apart. Without that 12, the whole delicate architecture would collapse into chaos.
Part 5. 20 intersections in equilibrium. Let's check out the grand finale here.
This is where the true scale of Franklin's genius reveals itself. He goes from being a clever puzzle guy to an absolute master of arithmetic constraint. He didn't just pull off this balancing act once or twice, he nailed the constant sum of 360 across the rings, and he used that central 12 anchor flawlessly. But here is the totally staggering part. This equilibrium holds up across exactly 20 distinct sets of intersections. We're not just talking about the obvious straight lines and circles anymore. Franklin designed the grid so that winding offset paths and super-specific groupings of numbers also independently sum up to 360. Imagine trying to balance a scale, but you have to keep it perfectly level across 20 different, overlapping, highly complex configurations on the exact same board. You tweak one number to fix set 19, and boom, you instantly ruin sets 4 and 7. The combinatorial explosion of possibilities is massive, yet he navigated all that noise to find the exact arrangement to satisfy all 20 simultaneously.
Let's really put this feat into perspective. Over on the left, you have the dizzying, absolute chaotic nightmare of 20 distinct intersection sets overlapping on a single grid. You've got concentric rings, intersecting spokes, and weird offset shapes, all demanding exact mathematical values. It's an arithmetic labyrinth where one tiny mistake breaks the whole system. But out of all that tangled, overlapping web emerges the result on the right, the singular, beautiful, elegant sum of 360. The genius isn't just in making the hard math work. It's in making something incredibly complex look utterly simple and uniform. It's the absolute mastery of raw complexity. You feed in chaos, apply unparalleled intellectual constraint, and out pops pure, unadulterated harmony.
So, looking at everything we've pulled apart today, I want to leave you with this ultimate reflection. What kind of mind does it take to achieve that level of perfect arithmetic harmony? To plot it all out by hand, with ink on parchment, way back in 1765. The ability to design a grid of this magnitude, balancing it perfectly on a single central pivot of 12, to deliver constant perfection across 20 overlapping sets. It's truly remarkable. It stands as a massive testament to the power of the human mind to seek out and create order. I really hope this deep dive into the raw historical data helped you visualize the brilliance of Franklin's puzzle and what pure mathematical equilibrium actually looks like. Keep questioning the world around you, keep structuring your knowledge, and above all, stay curious.